Hi, this is Reese with Research, and in this video, we will learn about projectile motion. Projectile motion occurs when an object is launched into the air, and that object has a parabolic trajectory. Now, when we learned about kinematics in one dimension, we saw objects that moved along the x-axis, so a car that's driving left and right, and we saw objects that moved along the y-axis, so they were going up and down. But we are dealing with kinematics in two dimensions, which means our objects are not only moving along just the x-axis or just the y-axis, they have motion in both axes. And so, what does that look like? Well, imagine a person is throwing a ball. We know that ball is going to move to the right, but it's also going to go up, and then it's going to come back down. So we have motion to the right, that's along the x-axis, and we have motion up and down, that's along the y-axis. So how does this affect your problem solving? Well, when you're answering projectile motion questions, you're going to need to break the question down into an x component and a y component. The x component represents the x-axis, and the y component represents the y-axis. To understand this, let's look at an example. So we have our person, and they're throwing their ball. It's moving with projectile motion, it has its parabolic trajectory, and what I want to do is analyze the velocity vectors. So initially we have some velocity v. That's the velocity that the person threw the ball with. But this velocity vector is at an angle, and that means it can be broken down into an x component and a y component. The x component is called vx, and the y component is called vy. Vx, which is the velocity in the x component, is what's driving the object's motion to the right. Now Vy, which is the velocity in the y component, is what's driving the motion up and then down. And together they form that parabolic trajectory. Now let's take a look at the x component. The x component in projectile motion is uniform motion. That means the x component has no acceleration. How does that affect our velocity vectors? Well, look at the velocity vector Vx. It never changes. It stays constant the entire time. And that's because the object is moving with uniform motion. So when you're doing a projectile motion question and you're solving for the x component, you can use the uniform motion equation, which says that Vx is equal to delta x divided by delta t. Now let's take a look at the velocity in the y component. Now the y component is free fall. So that means there is acceleration in the y component, and that acceleration is the acceleration due to gravity. So that would be negative 9.8 meters per second squared. Now if there's acceleration in the y component, that means the velocity vector Vy is going to change. So initially it looks like this. But because gravity is pushing down on this object, it's going to slow down as it goes up. And that means the velocity vector Vy is going to get smaller and smaller and smaller as the object goes up until it reaches a maximum height. At that point, there is no velocity in the y component. So Vy is equal to 0 at the maximum height of the projectile motion. And then, because gravity is still pushing down on it, the object changes direction and starts falling down. And then you can see the Vy velocity vectors start getting bigger because the object is speeding up as it's falling down. And now because the y component is free fall motion, you can use your kinematic equations when solving for variables in the y component. So you would use the same kinematic equations that you use for free fall for projectile motion. To summarize, What we just learned is that projectile motion will have an x component and a y component. The x component is uniform motion, so that means Vx is constant, and you can use the uniform motion equation. Vx is equal to delta x divided by delta t. Now the y component is free fall motion, so that means the acceleration is negative 9.8 meters per second squared. And when you're solving for your different y component variables, you can use the kinematic equations. Now here's what people usually get caught up on. If you are given the initial velocity v, how do you find vx and how do you find vy? Well, you have to use trigonometry. And when you set up a right-angled triangle with vx, vy, and the hypotenuse v, you can use trigonometry to solve for Vx and Vy. And what you find is that Vx is equal to V cos theta, and Vy is equal to V sine theta. So when you're answering projectile motion questions, if they give you the velocity of the object, you can use the Vx is equal to V cos theta and Vy is equal to V sine theta to find Vx and Vy. Now, a lot of students find projectile motion difficult to understand because we're moving from one-dimensional motion to two-dimensional motion. So you have to use the x and the y component, and it can get a bit overwhelming. So what you need to do is you need to practice, practice, practice. And so I've posted projectile motion questions for you to test your understanding. Because honestly, projectile motion is just uniform motion and free fall motion. And if you can understand those individually, then you can bring them together and understand projectile motion. So try those questions to test your understanding. And with that, that's the end of our brief introduction to projectile motion.